All right, here is a 9 for related to your unit on Pythagorean theorem. So I'm going to do it a couple different ways. So these are the 9 questions. If you haven't done this, if you're watching this at home and you're practicing, try them again, see how well you do. And then if you want to fast forward to the ones you don't know, I'll explain the answers to them. So here are your 9 questions. The first question asks us to estimate the square root of 35. Now, this symbol means approximately equal to, approximately equal to. And all you have to do is draw an equal sign with a dot above it. Or if you wanted to, you can use those two wavy things as well. They can be the same thing. So because 35 is not a perfect square, meaning what number multiplied by itself gives you 35, there is no actual number that will multiply to give you 35. There's ones that are close. So in order to estimate, we use this number line. The square root of 35 would fit between the square root of 25 and the square root of 36. That makes sense when I say the square root of 35 fits between there. And since this is a perfect square with the square root of 5, and this is a perfect square with the square root of 6, we know that the square root of 35 right off the bat is 5 decimal something, right? Because it has to be 5 because it has to fit on this number line. And since all the numbers on that red line are the number 5 decimal something, that's true. But how we figure out what the something is we estimate where it would be. Now, we would probably all agree that that's a pretty good location for 30 square root of 35, right? In which case, the proximity to 5 and 6 is pretty close to 6. It's probably like 5.8 or 5.9. I'm going to guess 5.9. And my answer, without using a calculator, is the square root of 35 is approximately 5.9. Check your answer with a calculator. Press 35 and then the square root symbol. And the actual answer is 5.19 or 9164797, an irrational square root. The second question, exact same thing, except this time it's asking us to estimate the square root of 90. So the two that it falls between are the square root of 81, which is 9, and the square root of 100, which is 10. So without going any further, you know the answer is going to be 9 decimal something. Its location is pretty close to the middle. Is it closer to 9 or closer to 10, the square root of 90? It's just a little bit closer to 81 than it is to 100, right? But we're going to guess, I'm going to guess, 9.5 exactly, roughly. 9.4 is a good guess as well. But if I put this in and square root it, it's going to be 9.48. Yes, 9.48, which rounds up to be 9.5 roughly. And your last question asks you to estimate this. So since the square root of 49 is 7 and the square root of 64 is 8, the square root of what number is approximately right in the middle? Well, 50 and 64, we could say 56. 56? How many said 56? How many said 57? I would say the square root of 56, which is right in the middle, or the square root of 57, or if you said the square root of 55, anyone say 55? Let's check fifth square. So we're going to check our answer. Square root of 56 should be roughly 7.5. Yeah. So the best answer is the square root of 56, but if you had square root of 55 or the square root of 57, you would still get full marks for it on a test. Okay. If you said the square root of 50, it would be wrong because the square root of 50 would be closer to here than the middle. Our next question says, is this 90 degrees? If it is 90 degrees, it should follow what law? The Pythagorean theorem. It shouldn't be that they add up together, because Pythagoras did not say the A plus the B equals the C, did he? He said the area of this square, or A squared, plus the area of this square equals the area of the third square on the hypotenuse, or A squared plus B squared equals C squared. So if you did it with pictures, you would put 81, you would put 144, and you'd put 225. And you'd say, because 81 plus 144 equals 225, then yes, it's 90 degrees. That's one way to do it. Another way to do it is to just take your formula and substitute A is 9, B is 12, C is 15. When you do that, you end up with this. And therefore, you could also say, yes, it's 90 degrees because a squared plus b squared equals c squared. Now, if that didn't work and it was different numbers, you'd say it could be a triangle, but because it doesn't follow Pythagoras, that is not a 90-degree angle because Pythagoras only works with 90-degree angled right triangles. Our next question gives us two sides of a right triangle and asks us to find the missing side. I'm going to do it two different ways. In fact, I'm going to clone it right now. On your test, you may or may not clone. Bring it over here. You may be asked to solve with a picture, or you may be asked to solve with the actual theorem. So if you do, Alexis, if you do, here's what you would do. First way, you would draw that, and then inside, if the side length is 2, the area is 4. If the side length is 10, the area is 100. If the side length is x, the area would be the sum of these two, which would be 104. That's with the picture. If that's true, then how long is x? Therefore, x is equal to the square root of 104, which is approximately equal to, if we were guessing, what would we say, 10 decimal 2? 10 decimal 3? 10 decimal 2? I'm not using a calculator. I'm going to say, so look here, make a note of this on your page. This is the answer. The length of x is equal to, not approximately to, but exactly equal to the square root of 104, which is approximately equal to 10.2. Does that make sense? Exact answer, approximate answer. Now, the other way you could do it is with a formula. A squared plus b squared equals c squared. Remember, your a's and your b's are the two legs of the triangle that make up that 90-degree angle. So 2 squared plus 10 squared equals x squared, or 4 plus 100 equals x squared, or 104 equals x squared. At this stage in your test, you would square root this side and you'd square root this side. The square root of x squared is x. The square root of 104 is roughly 10.2. Any questions on that one? We're okay? Make sense? Your next question, this time it's given you a leg and missing leg and hypotenuse. If I use my theorem or my formula, a squared was going to be 2 squared, b squared is going to be x squared, and c squared is going to be 10 squared. Solve your exponents. You get 4 plus x squared equals 100. Algebraically speaking, what would I do next? If I want to isolate for x or solve for x, Ben, what would I do first? Get rid of that constant by removing 4 from both sides. X squared will equal 96. And then, Ben, take me home. What would I do to both sides here to solve? No, square root both sides. I know you did. Square root of x squared is x. The square root of 96 is going to be less than 10, maybe 9.8, roughly. I'm guessing approximately equal to 9.8. Double check with the calculator. Oh, that's not the right one. 96 square root. 9.79, which is 9.8. This question is your story problem. It has Mr. Bridges and Mr. Connell. Mr. Connell is running, and they're going to run around the gym. Mr. Connell runs around the gym like a normal gym teacher would, and Mr. Bridges runs halfway across, but then realizes he's losing, and then cuts across the middle of the gym to try and beat Mr. Connell, because that's the type of person he is. He's a little smaller, that Mr. Bridges. Mr. Connell would run 6 plus 10 plus 6 plus 10, which is 32 meters. Everyone agree with that? Mr. Bridges would run 6 plus 10 plus whatever this is here. Now, in order to calculate that, we have to think of this shape as a right triangle, which we know the 6 and we know the 10. If I attach squares to all of these sides, this square would have an area of 36. This square would have an area of 100. This square would have an area of 136. And if the area of that square is 136, then the side length will be the square root of 136. Square root of 136 is 11.7. So Mr. Bridges would have ran 6 plus 10 plus 11.7, which is 30, no, 27.7 meters. But we're not done yet, are we? The question on your story problem would be, how much farther did Mr. Connell run? Which is the difference, 32 take away 27.7 equals. Add on to it, I'm going to add 0.3, that gets me to 28, plus 4 more. So your answer is 4.3 meters more. Therefore, Mr. Connell ran 4.3 more meters. We all okay with that? Question? Yes. No. Somebody has to still write it. Somebody forgot. Your next question is your perimeter question. So the perimeter is 24. And since perimeter of a square is equal to 4 multiplied by the side length, then 24 equals 4 multiplied by the side length. If I divide both sides by 4, the side length must be 6. Okay, algebraically speaking, perimeter equals 4 times the side length, or 24 equals 4 times the side length. Divide both sides by the coefficient. You isolate for s. 24 divided by 4, 6. Therefore, this is our square. If the side length of a square is 4, the formula for the area of a square is side squared, or area equals 6 squared, or area equals 36 square meters for that question. And your last question, perimeter is 10. So perimeter equals 4 multiplied by the side length, or perimeter equals 4 multiplied by the side length. Divide both sides by the coefficient. The side length equals 2.5. Once you have that, area equals side squared, or area equals 2.5 squared. 2.5 squared is 6.25. Your final area would be 6.25 meters squared.